in this example, it's going to be a little bit more of a complex example than anything we've really kind of covered this far. We're going to be working pretty heavily with attributes and attribute promotion and all sorts of concepts that we've discovered in the last few sections and chapters. So if this is seeming like it's flying over your head, don't worry about it. You can skip it and come back to it later. I just want to have something here so that you can feel comfortable, at some point coming back to it and kind of really diving in. Because I really feel like this belongs near our attributes section and our attributes learning, since we're still in SOPs and we haven't really gotten into any of the dynamic stuff. So if you need to skip it, don't feel bad about it. You can always come back, and you're not going to miss anything out. You're not going to miss out on anything by, continuing on with the course if you feel the need to move on beyond this point. But I just thought at this point it would be nice to have sort of a fun project that we actually have like more of a satisfying result, a more Houdini looking, awesome, crazy procedural thing. So without further ado, let's dive in and get to the meat of it. So let's start building this thing. I've got a new scene here, and I'm just going to hit the D key and change the background to dark. Awesome. So over here, let's sort out a new geometry. Geo. And then I'm going to dive inside and throw down a platonic solid. And we're going to crank this up to the dodecahedron level. So you can see it's just a bunch of pentagons all sort of butted up against one another. But I wanted to add a little bit more variety of shapes, so we aren't just working on a bunch of pentagons for this. So what we can do is add a bevel. And the bevel in Houdini 18 has been updated. So we're going to do it with both the Houdini 17 bevel and the Houdini 18 bevel, just so we can kind of see what the difference is there. So I'm going to paste those down right here. So in the Houdini 17 version, let's just wire this in. What we want to do is go up to the fixed distance, and I'm going to just inset it about 0.25. And you can see it gives us all these interesting shapes. But I want to maintain that sort of polygonal feature that was on this main face here, or that's left over from the main shape. So I'm going to hop down here where it says allow vertex splits and tick that off. So you can see we get these sort of kite shapes, some rectangles, and some pentagons. I think that's a nice variety for this example. So to do the similar thing in the poly bevel in Houdini 18, we're going to wire it in over here and set our display flag. We're back to normal, and we're just going to inset it 0.25. And you can see here that its fillet shape by default is set to round. Over here on the Houdini 17 one, the fillet was set to chamfer, and it had 2 divisions. So on the Houdini 18 poly bevel, we're going to set this to chamfer and then set the divisions to 2. And now these two results should be exactly the same. So you can continue following on from here in whatever version of Houdini that you're in. Next thing I'm going to do is throw it on normal, just because I want to have some nice hard edges. So I'm going to crank this cusp angle down, and you can see that we get this sort of nice hard edge there. Which I think works well for this example. I kind of wanted some more angular looking geometry. We'll be continuing to reapply normals throughout this thing so we can maintain that look in our viewport. So this whole effect is sort of built around the concept of extrusion. So we're going to do a poly extrude next. I'm going to wire that in. And I'm going to just hop up to the top here and then just crank up this distance a little bit. You can see that it's more or less just looks like it's scaling this thing up. That's because all the faces are connected. But if I go to divide into individual elements from this menu, you can see that each face is now extruding independently. Now this is where the concept of using attributes in our nodes as parameters comes into play. So if we look over here on our poly extrude, we go to the local control tab, you can see that there's local attributes, and this first one is called distance scale. So if I tick that on, you can see by default it's set to attribute of z scale. That means that it's expecting an incoming primitive attribute that will sort of act as a multiplier on this distance value up here. So we need to supply that attribute. To do that, I'm going to just create it using an attribute create. And then up here, we'll set this attribute to z-scale. And then if I go and crank this up to a primitive a primitive attribute, you can see that the value is set to 0 by default. Now, if I drag on this slider, this z-scale attribute is kind of working the same way our actual distance attribute did, but it's actually a scaling factor on this. So when I scale this up to 1, it's going to have extruded this to 0.2. So now, in order to get like a nice kind of fall off, what I want to do is create another point and then kind of pass that point through this so that we can have a varying extrusion, like a wave of extrusion that passes through this object. So I'm going to throw it on an add so we have a point from which to create our fall off. So add, and then I'm going to jump up here and just tick this box on so we can create a point at our origin. And if I click the manipulator here, you can see here's the point. I'm just going to drag it up off to the side. It's a little hard to see, so I'm going to hit the D key, geometry, and click increase my point size. So you can see that that has increased our point right there. Awesome. So now what I want to do is do the attribute transfer trick to create our fall off. So let's create an attribute transfer. And let's just wire this in here. We'll create a new, now this add, if I middle mouse click on it, it only has one point. It doesn't have any primitives. And up here, we created a primitive attribute because the poly extrude is expecting a primitive attribute to do this type of thing. So what we have to do is actually transfer point attribute in this situation. So I'm just going to go back to my attribute create here. I'm going to set its value back to 0, and then I'm going to change it to a point attribute. And you can see that the poly extrude just pops back out because it's no longer receiving any z-scale information. It's just simply doing its distance extrusion on its own. So now, if I take this attribute create, copy it, paste it over here, and wire it in underneath the add, then what we'll do is we will give this one a value of 1. So our attribute create on the left has a z-scale point class attribute with a value of 0, and then the attribute create coming out of the add has a z-scale point class attribute value of 1. All right, so now down here on our attribute transfer, if we take a look at it, it's set to transfer primitives. Now we could be transferring primitive attributes if we weren't maybe using an add, but for this example, I wanted to kind of revisit promotion. So we're going to tick off primitives, and from points, we're just going to select our z-scale attribute that we're transferring between these two, just like we've done before. I'm going to throw it on a visualize so we can see that. Wire this in here. Visualize by default is set to position, I think. Yeah. So in the visualizer tab, instead of P, I'm going to just type in z-scale. You can see that it all turns red. It's because the conditions tab on the attribute transfer is transferring a distance threshold of 10, so that's pretty far. I'm just going to bring that back down. You can see that fall off starting to happen here. I'm going to actually bring it all the way down to 0 and give it a blend width of something around 1.5. And if I just go up here and grab the add, grab the manipulator, and bring it in, you can kind of see it having that effect over our geometry. So, but because this is a point attribute at this point, we can't really feed this into our poly extrude and have it do anything. So I'm going to throw down an attribute promote to get this back into a primitive attribute. So if I select under the original name from the dropdown, you can see z-scales there. And it's detecting that it isn't detecting the original class. It's actually set by default to detect a point class. And then we want to change it into a primitive class. So when we do that, and then we wire this visualizer down here, you can see that now every polygon has one color on its face. Whereas before, it was just sort of the smooth fall off. Every point had its own color. Now every face has its own color. And that color is the attribute z-scale that we need to drive this extrusion. So now if I pop back out here, grab our add and move it around, you can see that it's kind of doing an individual, it's using that fall off to drive the extrusion distance. So now what we want to do is maybe let's just add a little bit of animation to this. So I'm going to drag the add I'm going to drag this add node way out over here. So maybe a value of about 2.5, a value of about 2.5 in X, and then let's leave it at about 0.6 in Y. And I'm just going to option click on this parameter to sort of set a key there. I like to color code things that have keyframes in them, so I'm going to hit the C key to bring up my colors with my add selected, and I'm going to just add a green there because green to me signifies it has a key on it. This is green, keys down here are green, so that's sort of what my coloring convention is for that. So then I'm going to just drag my slider or my timeline slider all the way out to frame 240, and then we will move it across until that it looks like that extrude goes away, like so. And then I'm just going to option click the point parameter here to set a key. So now if I slide my timeline back and forth, you can see it's doing its thing. Great. So now the next thing that I want to do with this is I want to inset these faces a little bit. And if you look down at the poly extrude, you might guess that we're going to be using this inset function to do that, or this inset parameter to do that, because inset scale is indeed a thing down here. We could provide another attribute, another primitive attribute to modify the insetting scale like so. But I found that this actually led to some pretty buggy behavior when I was working on this. So I opted to use a different method, which we're going to go over right now. So let's turn this off. Let's set our insetting back to 0. And we're going to throw down instead the primitive SOP. Primitive SOP has a whole bunch of functionality on it. Can do all sorts of things, but we're mostly concerned with this transform. You can see it has this option here to do transformation. And what it's going to do is find every primitive and then allow us to translate based off of, the centroid of that primitive. So if I do like just any old translation like this, it's going to just move everything. But if I go to scale and start scaling it down, you can see it's doing a similar thing to our insetting, but it looks a little bit wonky because it's trying to actually inset the sides of these faces, the sides of these extrusions, which we don't want. So we can actually use a group generated by the poly extrude to have it only focus on doing its thing to the front face of the extrusion. So if we go back to the extrusion tab on the poly extrude, you can see here that it has an output front checked. That output front is these front faces. And there's another option here to create a front group. So if I turn that on, you can see by default that is set to extrude front. So I'm going to just copy this, and then I'm going to go down to the primitive, highlight it, and then up here you can see where it says source group. I'm just going to paste in that extrude front group. You can see everything bounces back and gets nice and symmetrical because we're only doing that the scaling function on that front group. Now it looks like my normals are messed up, so like we were saying, I'm just going to throw down another normal and wire that in here and drop the cusp angle down to 0. So you can see that we've now inset everything a little bit, but I want this insetting to also be driven by this this fall off that's coming through. I want it to both extrude outward and also inset at the same time. So I'm going to actually just use that attribute on the scale here. So if I type in at Z scale, because that attribute still exists on our geometry, if you middle mouse click, see that Z scaling attribute still on the primitive. You can see it gets a little bit oblong here because it's only applying it to the X dimension. So to make this easy to deal with, so I only have to edit expressions in this one little area, I'm going to right click, I'm going to say copy parameter, I'm going to go over to the Y value, and I'm going to highlight it and say paste relative reference, and then hit tab, and right click and paste relative references again, and then hit tab. Now you can see that it is doing that scaling on all of these. So if I go all the way out, you can see it's actually scaling up from 0 to 1. And we actually want the opposite of that. Because what we had first was we want it to be fully scaled, so there's almost not, so that it looks like what we had here. And then we want it to scale downward. We want it to inset. So we can actually take the complement of that. If we have a scale that's going from 0 to 1, we just need to make it more or less start at 1 and subtract from it the z-scale that we're supplying. So I'm just going to put a 1 minus z-scale here. This is the complement. So we're taking now the complement of this z-scale parameter, or z-scale attribute, I should say. So now you can see that as this add passes through, it's shrinking those faces and extruding them at the same time. So nextly, what we want to do is we kind of, to get that fractally behavior, it's about kind of repeating this sort of instruction over and over and over again. Now, what we could do is just maybe grab the poly extrude, and you'd think maybe we just wire it in again. And it's doing it again. And then we can do that again and again and again. And essentially just keep copying and pasting this, and it keeps doing that instruction over and over and over again. We just drag this back out, and you can see it's starting to exhibit more fractal-like behavior. But this isn't the very Houdini way of doing things. There's a better way, and that is using the for loop. So before we use for each loop, which would detect certain parameters or attributes on our geometry and use that to iterate over the geometry in like an organized way, instead of a for each, we're going to use a for loop. For loop just allows you to repeat the same instruction on all the geo over and over and over again. So, a set number of loops that you define. So let's throw down for loop. You can see for loop with feedback comes up right here. Just click on that, and it throws down another orange blob. And if we get down to the bottom here, you can see that it's saying that its iteration method is by count instead of by pieces or points. That's really the only difference here. And so when you have by count turned on, you get these number of iterations that you can do. I'm just going to crank this down because this can get pretty heavy. If you go much beyond like 5 or 6 iterations, it can get kind of gnarly on your computer because we are creating new sets of polys every time we extrude. And so it can get like extremely out of hand. Now, how are we going to implement this? Well, we wanted to just kind of perform this little poly extrude instruction over and over again. So I'm going to just bring in the repeat begin one above the poly extrude, and then kind of this blob goes all over the place. And then I'm going to take this the repeat end and put it underneath that primitive. And so now if I highlight this, you can see that it's sort of following this chain off here. The point of this for loop is that we don't really want this. We don't want to have to copy and paste this a bunch of times. We just want our parameters in one place that we can sort of have it control through the loop. So we don't need these, just delete them. You can see that we're kind of back to the same result that we just had. And the number of iterations that I crank up is effectively like how many times we're going to copy this poly extrude and primitive combo down the chain. But it's all in this nice contained little organized, neat setup. So let's just go back up here, and I'm going to kind of dial some of the settings of this down a little bit so we're back to something a little bit more recognizable. And let's turn on the normal. Yeah. So I'm going to set the distance to 0.01 for right now, just because this really helps me see the patterns that are emerging out of this. You can see that every iteration that we go through, I mean, it's getting, if I do crank this back up, you can see it's getting pretty crazy. And these little tiny bits that, are at the end of the last iteration of the loop are starting to get like really sharp and pointy. And it would be nice if there was a way that I could scale this down so that every time we go through the iteration of this loop, we scale it by slightly less each time. And the way to do that is to use metadata of our for loop. So if I select the first node and say create a meta import node, it does this thing where it drops down this this repeat begin one metadata one node. I'm just going to rename this meta data so that it's just a little bit shorter. So now let's see if we can work on some sort of expression inside of here to drive this distance parameter. Now we need to reference the metadata node. So the way I'm going to do that is I'm going to go up here and click the gear icon and say add a spare input. And this is kind of a weird, quirky way of doing things, but it works pretty well. And what basically clicking that just did was created this spare input down here at the bottom. So I can drag this metadata node right in there, and that now this node has access to it. And it's kind of hard to see, but there's a very faint purple line that is connecting these two, just to signify that they are that this is referencing that metadata. So now to kind of clean this up and make it a little bit easier to work with, I'm going to go back up to the gear and say edit parameter interface. And I'm going to collapse down the extrusion folder, spine control folder, and now I'm just going to move the spare input right up to above the distance parameter right here. So if I click apply and I scroll up over here, you can see at the top we've got our spare input 0 metadata. I'm going to just rename it using just changing this label. I don't want to change the name right here, but change this label. I'll name it metadata. And so, and I hit apply, and you can see that that is sort of a nice descriptor for us. That's all cleaned up. But now what we want to do is we want to access the iteration detail attribute of this metadata node. You can see the detail attributes it has right here are listed. Iteration is one of them. So to do that, I'm going to use the detail function, but I'm going to store it in another parameter just to make things easy for us. We could one-line this entire expression, but it gets very long and hard to see. So I wanted to kind of break it out into one parameter, channel referencing another parameter into another parameter so that we could, you know, kind of just have it a little bit more organized so our final expression is much more concise. So to create the iteration parameter, we want to use an integer because iterations are whole. You can't have a half of an iteration. I mean, it loops over once and it loops over twice. So, and so on and so forth. So right under the metadata node, I'm going to grab this integer, drag it right under this metadata node that we created here, or this metadata parameter we created here. I'm going to call this I. Just something short so that it isn't too long in our expressions. I'm going to go tab, and then for the label, I can write a longer message here. So type iteration, hit apply and accept. So I've got an iteration here, and I can write my detail expression here. I'm just going to click on it so it gets wider, and we're going to start writing out that detail, the detail function to access this metadata node. But now if you hover over here, you can see that this is another quirk about this using a spare parameter, spare input thing, is that you can refer to this spare parameter as in expressions such as -1. So if we go to iteration here and type detail, normally it would want, I gotta spell that right, AIL. Normally it's asking for a string path to the node we're trying to get detail from. But because of the spare input, we can just type in -1. And that just references this metadata node above. Nextly, the attribute we want is iteration, and then we throw down a 0 at the end, close parentheses, and hit enter. Now we have iteration. You can see that it's set to 2 because as we iterate through iteration, computers count from 0. 0 is actually kind of 1 in computer language, so the 0th iteration, and then the first iteration and second iteration are the iterations 1 through 3. So we don't actually want to be using this. We don't want to be using 0 for our iterations. We're going to label them in human language, so we're just going to add a +1 to that. So that really is going to send us through our iterations starting counting at 1 instead of 0, which comes in handy because we want to divide our distance by this iteration value. The higher the iteration value, the smaller the distance. So say divide by, and I'm going to right click up here, say copy parameter, and paste relative references. You can see that now each iteration is extruding slightly less and less and less. Again, up here, adding the +1 means that on the first iteration, we aren't dividing by 0, which would create like a hole in the universe or something. You're never supposed to do that. It doesn't crash Houdini. It actually just doesn't work. That first iteration kind of just is like left blank or something like that. So now we've got this, this distance is sort of decreasing. Let's go back over here and say I want to try messing around with this distance right here. It's sort of now a part of this expression. You can middle mouse on this number and start dragging the ladder and getting results from it. But I find that that's a little bit convoluted. So what I want to do is maybe extract this distance into its own parameter. We'll call it a distance factor. So let's do edit parameter interface one more time. I'm going to grab a float this time because distance is just any decimal value. And we're going to put that right above the distance and right below our iteration here. And I'll call this dist factor. And down here, distance factor. Hit apply and accept. And I'll set this to 0.05 like we have below. And then I'm going to right click, copy parameter, select the 0.05 and the distance attribute below, and paste a relative reference. So now we've got this our own independent slider for this. What I'm noticing is that it's ranging from, its default range is from 0 to a value that's way too high. So I'm going to just go back to edit parameter interface one more time, find that distance factor we created and change its range from, instead from 0 to 10, from -1 to 1. So now our slider's sort of in a normal range here. All right, so now let's see what happens. I'm going to just crank this up to 4 or 5 iterations so you can see what's happening. You can see here it's kind of getting a little bit slowing down quite a bit. Now if I hit play, it's taking quite a bit of time to get between each frame. So I want to just optimize this a little bit. Like in the end, I'm not afraid to wait for a long cache for this. That's not a problem. But while I'm iterating, I want to be able to work a little bit faster. So I'm going to just focus on one of these faces of our original polybevel. Now let's see here. I think that I'll work on this one. So I'm just going to hit my select tool with the polybevel selected here. Hit my select tool and make sure I've got primitive mode selected. I'm just going to select that pentagon and hit the delete key. You can see it throws down a blast for us. I'm just going to switch it to delete non-selected. So we're now just focusing on this one pentagon. We can crank up the number of iterations and it's not going to process the entire sphere. We can just sort of evaluate what it's doing with this one sphere here. Let's go back down here and highlight our normal. And you can see that it's got all this great geometry that's happening, and when I click play in our timeline, it's moving much more smoothly. You get a much more kind of a real-time view of what's going on. Great. So now what I'm noticing is that it looks like all of our levels of extrusion are happening all at the same time. You can see that each iteration is kind of coming in here all at once. It's all doing its thing. And what I thought looked really cool was to actually time offset this. So, I mean, while this looks nice, it's doing a little contraction there and then it's expanding back out. I thought I could get more play out of it by doing each extrusion at a different time. And that's where one of my favorite nodes, the time shift node, comes into play. So what we're going to do is time shift each iteration of this loop. So let's just look at what a time shift is. I'm going to throw one down, time shift. There we go. And I'm going to wire that into the coming out of the Z-scale attribute of the add. I'm just going to throw this time shift right here. And by default, you can see that the frame parameter is set to $F. If you've got a frame here, you know, if you click on the frame and it's not showing $F, it's just showing what frame we're on. So if I scrub this, it's evaluating to, you know, frame 118 down here. If I click on it, you can see it's $F. I'm going to template the add itself and then just add something to frame. Let's add 10 frames to this frame. So now if I'm not seeing it on the template, so I'm going to actually click on add and have the display flag set to the time shift. You can see that if we go down here, that this time shift is now 10 frames ahead of where the original add was. And you can see that by going on the time shift and seeing $F plus 10 is frame 90. We're actually on frame 80. So it's actually looking through time, which is a really powerful thing. I mean, tons of cool effects can be done by just simply looking at what the geometry is doing at different times and adding them up together in interesting ways. So let's kind of build this out a little bit more. I'm going to say up here that we actually don't want to lead this add animation. We actually want to trail it. So I want to put a minus sign here. So now it's going to be just trailing behind our add a little bit. Cool. So what we want to do is we want to transfer this attribute onto our geometry at a different point in time every iteration of the loop. And every time we go through the loop, we're going to want to reset this attribute create Z-scale back to 0. So really what we need to do is just sort of take this begin node and kind of wire it up here above the attribute create so that this transfer is occurring inside the loop. And then we'll wire in our time shift so that it is also being fed in and time shifted along with that. So let's go and create a little bit of room for ourselves above the Z scale. And I'm going to shake off, I'm going to deselect and just grab the repeat begin one. I'm going to shake it off and it detaches and I'm going to wire it in up here now. So now we are encasing this attribute create Z-scale attribute transfer thing inside of our loop. And we can do a similar thing now like we did with the poly extrude, which is create this spare input and use the metadata to drive an iteration value. So I'm going to go up here and do that. I'm actually going to, let's grab the time shift node. I'm going to click the gear and say add a spare input. like we did before. I'm going to grab the metadata node and drag it into the spare input. And then I'm going to create our parameters that we want to use. So again, like we had before, I'm going to want an integer. So I'm going to throw an integer down here. That's going to be our iteration value. I'm going to call it I, and I'm going to label it iteration. And then, oops, it won't take unless you hit enter. So I'm going to type that again, iteration, and then hit enter. And then up here on the spare input, I'm going to relabel it metadata as well. And I know that I'm also going to want a special parameter to drive this, just like kind of how we did down on the poly extrude when we extracted our distance factor here. I'm going to want a my own little slider where I can determine what the distance between the distance in time between each loop should be. So we're going to create another one called offset. And the offset is going to be, the offset can be a float value because time is a float. So we'll do that. We'll throw that over here. And we'll call this time, we'll call it offset here, but we'll label it time offset. And hit apply and accept. So now this will work on float frames. So I'm going to actually, instead of using $F, I'm going to use $FF, which stands for float frames, and then untick integer frames, which will allow us to evaluate this to frames that are, that are subframe. It'll allow us to evaluate to, point something if we wanted to. So now instead of -10, I'm going to just go down here to the time offset and say -10 here, and then right click, copy parameter, go up here, select. Or actually, I'm gonna set the time offset to +10, but I want to keep the minus here because it helps me remember that we are trailing up above. And then delete the 10 and right click. So time offset, right click, copy parameter, up here, paste relative reference. There we go. Now we can control that offset. And it'll control the gap in time between our loop iterations. But we need to get that iteration involved as well. So to do that, we're going to multiply the offset by the iteration. And to get the iteration, we need to use that detail function again. So I'm going to do the same thing. I want to grab from our poly extrude. I'm just going to go and select this expression, including the +1, this detail expression on this iteration value, copy it, go back up to the time shift and to the iteration and just paste it in. And so now this is looking at its spare input, which is -1, looking for this metadata, looking up the iteration value, which is this. You can see it's created this purple line going into the time shift node, and it's doing a time offset as such. So if we go back down here, see if this is working. Oh, it's not actually. It's not time offset yet because we haven't applied this iteration multiplier to our offset up here. So I'm just going to right click the iteration, say copy parameter, come up here and multiply our offset by that by saying adding an asterisk and saying paste relative references. So it's looking for CHI. So now when we play this back, you can see we get one level extrusion, another one, and then they all sort of take turns going off. Now this time offset is very small, so I'm going to increase it to something more obvious, like 20, so we can see what's happening here. Let's click play. You can see one level extrusion happening, another one. It's just sort of all kind of building off of itself. Now, this is actually happening quite late because this time delay is so delayed. So I'm going to just add a constant number of frames here. Let's say we'll crank this up to something like, we'll start at frame 96. So if I just add plus 96 here, it's going to move ahead so that when we go back to frame 0, things are starting earlier. And you can see those different levels of extrusion happening at different times. It's kind of interesting. But this is giving rise to a weird situation. If you look around the edges here, we're starting to get this error where it's starting to glitch out because it's extruding some faces when their preceding loop is like really small because it's been time offset. So what we need to do is figure out a way that we can correct for this. And we're going to use some more attributes to do that. So what's a way that we could solve this problem? We could say, well, if there's a really tiny face, you know, these faces are really, really tiny. They probably don't need to be extruded if they're really small. We could add a scaling factor to the overall extrusion size based off that, based off the area of the primitive. So we can measure the area of the primitive using a measure SOP. So let's throw it on a measure. And if I'm going to just wire it in up to this, our initial poly bevel up here. And if I enable that, you can see that we get all these different colors, right? The measure is actually by default set to measure area of primitives, and it just kind of gives us a little like color code for, you know, primitives that are larger. So obviously these pentagons are the largest, the rectangles are you know, medium sized, and then these little kites are smaller. Let's look at our attribute spreadsheet. I'm going to go up here, split pane top bottom. And I'm going to go down here and right click and open the geometry spreadsheet. So in Houdini 17, the geometry spreadsheet is out in this menu, but in Houdini 18, they have now created submenus, and under inspectors, it's located here, geometry spreadsheet. So go to the primitive attribute tab here. You can see it's calculated a bunch of these areas for us. We don't want to calculate the area of this overall thing. We actually want to calculate it as the animation is happening on the fly. So we can take that. We can do that right above the poly extrude. And this color coordination, this color coding isn't really helping us at this point. I'm going to highlight this normal at the end. The color coding isn't really doing much. It's kind of confusing at this point. It's moving in and out of different ranges and whatnot, but it is generating this area for us. So let's go to a section where we're having some little like glitches, and this is sort of kind of a guess and check type thing. We're just going to kind of make sure we get it good. And let's see what the general shape of our areas are. I'd say like the largest area, the largest size shape of something at this level should have its, should be scaled to full. So if I just kind of sort by area, I'm going to click on one of the other tabs. Usually that helps it sort. And then if I go back to the area tab and click on it, you can see that the smallest area, or the largest area, is 0.005, and then the smallest is some really, really tiny number, you know, 6 times 10 to the minus eighth, you know, very, very close to, very, very close to 0, but not quite 0. And hence why we're getting these jaggies that are pointing out in the wrong direction. So let's use some VOPs and a range mapper, or a fit range, to kind of act as a multiplier on this overall extrusion distance. I'm going to throw down a primitive VOP. Primitive VOP is just like a point VOP, except it works on primitives instead of points. Actually, these are all just called the attribute VOP, and you can select whether you want it to work on primitives or points or whatever. It's just, you know, a shorthand way of getting this parameter set for you from the tab menus by typing in primitive VOP. So we're going to dive inside here, and then the attributes that we want to work on are none of these. We actually want to bind in our area and multiply it by our z-scale. We know that we have a z-scale attribute already. You can see it over here in our geometry spreadsheet. So if I go here, I'm going to bind in 2 attributes. We're going to bind in that area, which is a float value, and we're going to also bind in z-scale. So now if I were to kind of remap our areas between a value of something very close to 0 and this 0.05 value, that would mean that when the area reaches 0.05, we want it to scale to 1. So let's just add a little fit range here and wire in our area. You can see it's expecting a source min and max. If we want our maximum value of 0.05 to represent a multiplier of 1, we want our maximum value here to be 0.005 as well. So now any value between 0 and 0.005 is immediately stretched out to 0 and 1. So let's throw it on a multiply now. And we're actually going to multiply this value. It's going to get a little bit more real estate over here. We're going to multiply the z-scale and that together. So now our z-scale should have a scaling factor applied to it as well. If I bind this out using a bind export, we're just going to pipe this through here, and we're going to bind this to z-scale. You can see it kind of cleans up those edges. Now, one thing that I want to note, I don't want to actually bind this out to z-scale because z-scale is also being used by this primitive over here, and I want to sort of preserve that z-scale value that we're supplying here. So I'm actually going to use this primitive op to create two new attributes that are more descriptive of what they are controlling. So for this first one, I'm going to rename this to extrusion scale. Extrusion scale, just like that. I'm going to create another node, another bind export, and this is going to be called face scale. I don't want the face scale to be the same thing though, so I'm going to unwire. I'm just going to hold down Y and cut that wire. What I want the face scale to be, if we pop back out here into our primitive, we see that what we were using was the complement of z-scale. So we can actually just set that in here. There's a complement node. You can see that if you look really closely at it, it has a 1 minus x, which is basically what we were doing. Take 1 minus whatever we're bringing in. 1 minus what? 1 minus z-scale, which we're going to pipe in here. So now if I bind this out to face scale, we've effectively just renamed this to our face scale and done the complement function as well. And now if we go to our primitive, I can just right-click, delete channels. And then in here, I can type in at face scale, and it goes back to where it was. Cool. So now we've created that. Let's see if it's actually helping us. Our poly extrude is actually expecting, we changed, because we renamed this to extrusion scale right here. I'm just going to copy this attribute, the name of this attribute that we've created. You can see down here that our extrusion scale and face scale are making their way out of this primitive op. And I'm just going to hop down to the poly extrude, go to the local control tab, and then instead of Z scale here, I'm just going to paste in extrusion scale. And now we get these nice clean edges around the outside of our poly extrudes. Of our fractal geometry that we're creating here. We're not getting any more of those glitches. It's all just being sort of like tightly wrapped in there. It's looking good. Nice. So the last thing that I would want to do right after this primitive op is we're not using the Z-scale anymore, and it's there. So I just want to clean this up by deleting it. So let's say throw down an attribute delete, and I'm going to delete a primitive attribute and select it from the dropdown. Just want to delete Z-scale. So it's gone. And everything is still behaving appropriately for this. It's great. It's looking clean and awesome. And this is one of those things, this is one of those kind of things that's great about Houdini, is that you get things like this measure SOP that allow you to measure all these different types of properties of your object to find, and you can use these new attributes that it creates to kind of debug and fix and clean up and really get really smooth looking results in the end that are very clean and precise. Cool. So now let's just kind of work on the shape of this a little bit. I'm going to go up to the poly extrude, and I just want to kind of mess with the distance factor a little bit. And increasing that a lot, you can see that we kind of get this like sort of bulgy like behavior that's occurring. And it's not like scaling this distance as much as I would like it to every single iteration. So I'm going to let's do one more thing here. Instead of just simply dividing by the iteration, I want to actually divide by the iteration squared. So I'm going to throw down a POW function, and I'm just going to wrap this iteration value in that POW function. And for the first parameter, obviously it takes iteration, but then we throw down a comma and hit a 2 and close parentheses. You can see that it just takes whatever this value is in our first parameter and raises it to the value of our second parameter. So really this is like writing iteration squared at this point. So now you can see that we're getting even more drastic of a fall off between these. So I'm going to, let's just see here. If I start messing with this distance factor, you can see it's like bulging out a little bit still. I want to just check this primitive op and see what remapping these values of our source min and max scaling on our area will do for us, so we can just kind of experiment around with this shape a little bit. So to do that, I'm going to promote the source minimum and the source maximum. And then if we hop back out here onto our primitive op, we can see that it's got our values of 0 and 0.05 up here. I just want to try dragging this maximum value around to see if it gets us any different results. You can see that it's kind of bulging out on the sides here, but if we bring this up to a certain value, those start to shrink down. Let's just try messing with the lower value as well. You can see that it starts to clean up that edge as well. So we might want to have a little bit of a scaling factor on these lower edges as well. I found for my example that minimum value of 0.0001 and then a maximum value of 0.005 worked pretty good. Now I just want to make this extrude in the opposite direction. I have these all coming out right now. If I just go back up here to the blast and turn it off, it's going to think about it for a second, and then we'll see that we've got all these extrusions sort of bulging outwards. I wanted them to kind of generally stick to going inwards instead. So I'm just going to go back to the poly extrude and set the distance factor to some negative value. It's thinking about it, and it's updating here. And you can see that it's kind of turning itself inside out because every iteration of this inward extrusion is continuing to extrude inward and inward and inward, and then it's starting to fold back on itself. And so another thing that I did to kind of battle this was to use a modulo function to actually change whether it's extruding outward or inward on every loop of the iteration. So I'm going to go back up here and highlight the blast and turn it back on so we can just focus on this one shape here. So a modulo function. I'm just going to pop over here and throw down a null. And we're going to go look at the animation editor. On this null, I'm just going to create a parameter, edit parameter interface. We're going to throw it on a float. You don't have to do this. It's just for demonstration purposes, but hit apply and accept. The modulo function kind of gives us a way to kind of almost take the divide one number by another and then get the remainder of it. So for example, if I were to put in 10 mod 6, and mod is, to get mod, I use this little percentage symbol and hit enter. If I click on this parameter, you can see it evaluates to 4 because 6 goes into 10 one time and then it has a remainder 4. It doesn't really give you the how many times it goes into it. It just gives you more or less the remainder of whatever division you would be doing to it. So if we did something like this, where I'm going to just delete these channels and then throw down frame. So let's say at frame, and then say at frame mod 5, evaluate. So now when I move my slider, you can see that it's going through, and every 5th frame it's resetting to 0 and climbing back up. If I right click here on my parameter, go to channels and say add to channel list, you can kind of see this. It graphs that out a little bit for us. That's really hard to see, but you can see that this value is climbing up to 5 here, and then it drops back down to 0. So that's sort of what's happening with this graph. So what I want to do is look at the iteration value and have it mod every other one. So if I go here and say, pretending that frames are iteration value for right now, if I said every other iteration, I want you to change between a value of 0 and 1, well, we don't want to go between a value of 0 and 1. We want to go to a value of -1 to 1. So just like we used a fit range in our primitive op over here, there's also a fit range function here. And it also takes 5 inputs. So we're going to type a fit, open parentheses. The first parameter is the float value that we're evaluating. And then it takes 4 more values for our in minimum and in maximum. And then the remap values from the out minimum and out maximum. So we know that this mod will range from 0 to 1. So we know that the input is from 0 to 1. But we want to fit it between -1 and 1. So now, if we go here, and I'm going to just, sometimes this disappears, channel, add to channel list. You can see now it is modulating this between positive and -1. And if I play back the timeline, you can see it going +1, -1, +1, -1. Cool. So we're going to use this function here as a scaling factor on our poly extrude. So if I go back up here and you see our distance function here, we can just multiply this whole thing by that expression we just wrote. But it's going to look really funny if we go back to our scene view and try and play it back. You can see it's popping back and forth still because it is still working on this frame attribute. And we don't want to use frame. We actually want to use the iteration. So I'm going to right click, copy parameter, select frame, paste relative references. So now it's added our channel reference to the iteration instead. So every other iteration, it's going to pop in versus out. And if I set my display flag down here, you can see that our geo is now every iteration. I'm going to just go back up here to the top of our loop. Or no, I'm just going to go down here to the bottom of our loop, and I'm just going to crank the iterations down so we can see what's happening. So now our first iteration is being pushed in the negative direction. Our second iteration, boom, it's popping back out in the positive direction. So the next one should be pushing this, should be cutting into this face. So we go 3, it goes back in, 4, back out, and so on and so forth. Nice. So let's play this back and see what that looks like. It looks like I'm still getting some weird behavior right here, so I think I need to dial in my my settings on this fit range here. I'm just going to crank up the maximum value of my the maximum value of my fit range on my primitive op. I'm just going to crank that up a little bit until those little glitches go away. Now we can see we get that nice extrusion-like behavior that's going inward and outward. It looks very interesting, and it's great. All right, so now we're getting pretty close here. I think that what I want to do is see, I just want to push this a little bit. You know, when we were looking at this before, well, I want to see what I want to use in terms of a time offset. I'm not sure if I want to use a full-on 20 frame offset. I think that a value that I liked before was something more like 5. So it's like bring this in. You can see that it gets us some pretty gnarly looking behavior right away, and then kind of pulls back out from there. But I want to do maybe some more iteration. Let's see how many iterations we can do. Maybe 6 iterations. Just wanted to get really like a really nice intricate pattern at a certain point in here. So you can see like as it contracts inward, we're getting extremely dense polys down in here. And then they sort of kind of all start to spread out towards the end. Looking at this, I think that I want to just offset this a little bit more than 5. Let's try 10 for right now and see what that looks like. So it goes in, it comes back out, and then it's like we have this blooming star pattern happening for a while towards the end. I like that. But you can see that already on one polygon, this is running really slow. If I were to crank this up one more iteration, this might even just like crash the computer. So I'm going to hit Control S, and let's see what one more loop gets us. Let's crank this up to 7. And you can see it really gets nice here, but if I click play, it's keeping up pretty good, but this is really relatively slow in the long scheme of things. So, but yeah, look at all that detail. So many little polys doing their thing. So doing this over all of our geometry would be horribly inefficient. If I were to turn this blast off and have it calculate all of this geo, it would take quite a while, and we've got multiple frames that we want to cover. So one thing that I thought would be really cool to share with part of this lesson is a cool tip for using camera culling to optimize what all it is that we are actually processing. We don't need to process the whole sphere if we're not going to see it. So I'm going to just bring the iteration value down a little bit to something like maybe 4. or maybe, no, I'm going to bring it down to 3. So camera culling, let's talk about it. Camera culling is a way of taking the frustum of our camera. So I'm just going to I'm actually going to go up here to the blast that we have here, and I'm going to turn it off so we can get our whole geometry in the scene right now. So I'm just going to kind of pick a camera angle that I like. I think I like something like this for my example, where I got that nice pentagon in the middle and some various other shapes around the outside. And I'm going to just create a camera. So I'm going to hold down Control and click the camera icon. You can see that it creates our camera here. I'm just going to hit the lock key and slightly adjust it so we get a little bit more of a horizon. Maybe I'll back it out a little bit and rotate like so. Cool. So now what we want to do is say, you know, what if we could take everything that was outside of this camera and just delete it, get rid of it. We don't need to process it in addition to everything else. So we can go and take this information from the camera and use it in our SOP network. I'm going to unclick the lock real quick so that we can kind of see what's happening here. So now when I move away, you can see we've got our camera in position here. So let's dive inside this geo network and create a volume. The volume node will allow us to create, you know, a density, for example, and we'll give it an initial value of 1. And I think that by default, when I show this, you can see that we've got this just 1 unit cube in the middle of our scene. But there's an option here. We can select, instead of using a size and a center, we can actually use a camera to do it. And now we can select our camera from this list. We created that cam 1, hit accept. You can see that it's creating a little volume out of the frustum volume that is created by this camera. So now I've got a couple parameters here. I could change my Z near and far distances. This kind of, you know, is just, you know, to determine what distance from the camera is actually being considered a part of this volume. And one of the cool things about groups and volumes is that we could create a group based off of this bounding volume. So let's do that. I'm going to throw down a group node, and I'm going to say we're going to wire in our first input here, our geometry, and then the second input, we're going to wire in our volume. You can see that this second input's tooltip says bounding object. Now, by default, it's grouping everything and it's using primitives. What we're doing here is actually specific to only points. So I'm going to disable the base group, and I'm going to go to keep in bounding regions and hit enable here. And by default, it says bounding box. We're actually going to choose bounding volume, and you see it says it can only do points or vertices. And it throws an error because we don't have a point group selected. We only have a primitive group specified. So we're going to switch this to points. And you can see that nothing is really happening right now. That's because we need to just kind of tweak this isosurface value. So I'm just going to grab this slider and drag it a little bit, and you can see that points outside of this bounding volume are starting to be selected by that group. But it's kind of hard to see. Let me just pop back into our camera. So up here from the menu, I'm going to select our camera. Right now, it just looks like a big, dense white card. But if I go back to our group and highlight it, you can see that little points outside of our of the camera are starting to be selected. I'm going to hit the D key to make that a little bit more obvious. Under guides, I'm going to change the point marker size to be a little bit bigger. You can see these orange points outside of our camera are now being selected. Now what I could do is I could invert this, and it would select all the points inside the camera. You can kind of see them right here. So if I create this group, and I'll just call this in-cam, name the group in-cam, and then if I throw it on a blast right here, and I select the in-cam group from that blast, you can see that it's starting to delete away things that were in this in-cam. I want to do the non-selected version of that, so that's just the inverse. Now if I go back to our camera, you can see that it has kept everything inside the camera. But there's a little issue here. You can see it's processing all of this, but there are some pieces of geometry whose points are actually outside the camera. If we go up here, you can see, like, for example, this polygon right here. This polygon has 4 points, and only one of them is outside the camera, so it actually deletes that 1 point, and the result is this triangle that we're left with here. So this edge gets a little bit chewed up. This is another example of where promotion could be used to kind of take care of that. So what if instead of blasting away our in-camera point groups, what if we promoted those point groups to primitive groups? That way it would select this whole face, and then we would say, then it wouldn't delete that group. So here, where we've got our group, I'm just going to throw down a attribute or group promote. So group promote, I'm going to select our in-cam group, and then I'm going to convert it to primitives. Now you can see that everything being selected by that group is indeed outside of the camera. So now when I click blast, you can't see any little glitches happening within this range. Of course, it looks crazy outside the camera. You wouldn't really want to render that maybe unless you're after something like that. But inside the camera, everything's still intact. So to further optimize this, it looks like I'm grabbing a lot of this backside. And if I were to go up here and just bring in my Z far value, just bring that down a little bit, you can see that it's starting to clip items closer to the camera until they go away. So looking through the camera, I want to just push this as far as I can until I start to see issues arising. So here, now once I get down to a value of about 0.1, 0.8, you can start to see the horizon getting chewed away. I'm just going to push that until just a little bit beyond where I can see anything happening. So let's choose a value of maybe 2. So you can, if we zoom out, you can see that it's still deleting back faces, but it's just give us a little room to breathe in terms of that. So now that we've done this, we've effectively, if we look at our group right here, we see we've got 16,872 primitives. Down here we've got 4,000. So we've cut this into a quarter already just by doing that. So that'll increase our render times when we want to create our splines out of this geometry. But we could also use a setup like this to help with the actual initial processing of this geo. So if I were to kind of go up here, I'm just going to get a little bit more space here. I'm just going to copy this whole rig right here and put it before our loop so that we're only processing objects that are in the camera for our render. So let's go up here. I'm going to drag and get some room up here. And then I'm going to, let's just grab this whole thing. I'm option dragging it up here. So you can see that our camera is going, our camera wires way up here. I'm going to just bring this volume up here. I'm going to rename this camera volume. And then I'm going to detach this wire that's still attached here, and then wire in this and wire in that. So now when we get in here, so now we're only pre-processing this little chunk of geo that's in our camera. To keep this clean, I'm just going to option click here to add a knot, drag it out to the side, and option click and bring this down here. This null wasn't being used. This null was for our modulo example. I'm just going to delete that because we don't need that anymore. And so now what we can do is we can process many more iterations, and it will run a lot smoother on our computer than it would if we were just doing sort of, the entire sphere all at once. So I've got this up to, it looks like 5. Let's just try 6, see where that gets us. You can see that it's going pretty slow. It's still chugging along, but it's certainly faster than it would have been had we done this with, had we done this using the entire sphere all at once. So for this example, I would want to cache this out now. And I'm going to just do this at, I'm going to dial the iterations slightly back just so that we can get through this example, but you may want to do it at a level 5 or 6. Depending on what you're after. If you want wait for it. If you want something like this much detail, definitely push this as far as you can, and just don't be afraid to wait for a longer cache. That's all. I'm going to leave mine at 4 for this example because it clips along pretty fast, and I just want to get through caching this relatively quickly. All right. So after this, I'm going to throw down a file cache. And here I'm going to cache into a cache directory in the project file. So I'm going to name this cache. I like to use cache instead of the geo folder. I'm going to use $OS to denote the operator string, and also $hip name token to just name it specifically, name the file, put a folder in here specifically for the file that we're working on. And I'm going to call this the fractal cache. And let's see here. I'm going to see what frame range we want to work in. I'm going to go back to the camera. It looks like this. We did add an offset to our time shift earlier here, an offset of 96. I'm going to just middle mouse drag this number back until it looks like our extrusion is completely gone away, like so. And we'll use that as our start frame. In my case, it looks like that's about frame 43, so we'll go with that. So when I click play, the extrusion should start almost instantly. And it goes through, does the animation, and pops back out and is fully resolved by about, we'll just say frame 192. So down here in the start end increment, it's by default choosing the frame range of our project. I could just change the frame range here and that would automatically update this. So I'll just do that. 192, and 192 has now been populated into this field, and I'm just going to click save to disk. All right, so the caching is done. I'm going to click load from disk here and just click play. You can see it playing back faster than real time. I'm just going to hit the real time toggle down here in the lower left, and we can see that playback at its natural speed. Cool. So now let's just talk about a couple techniques for rendering. I know that in my example, I actually wanted to, have some splines that were actually kind of following along this geometrical shape to kind of add a little bit of additional interest to it. So let's export these. Let's export this geometry into another geometry and just create some additional splines. I'm going to create a null here, and I'm going to just call this our initial extrusion. And let's just hop up here to the object level, and I'm going to change the name of this to initial extrusion. Create another geo. And this will be our splines. So I'll call it splines, and I'm going to dive inside. And I want to object merge in the geometry from our other network. I'm going to just say, well, yeah, we can leave this on. Let's say ghost other object is good. We can kind of see the remnants of our other geo in here. So when I go up here and say, I'm going to select our object, we're going to go find our initial extrusion and then this initial extrusion null in all caps. Hit accept. And now our geo is in here. So what I want to do is just get the splines of this. So we can use an ends sop. The ends will allow us to use this unroll function. So we'll say unroll with new points. And if I say hide other objects now, you can see we're just left with a wireframe of all these splines that follow along with our animation. I'm going to switch it back to show all objects. So now they're completely overlaying one another. And I want these lines to kind of be offset from this surface slightly. So what I'm going to do is I'm going to peak them using the peak node. Peak basically will just move geometry along its normal. Now I don't know if I have normals right now. I have vertex normals here. I think it'll work with vertex normals. I'm going to do it before the end stop because I'm not quite sure how that attribute transfers. It's probably fine. In fact, I'll just do it after the end stop. And I'm going to just use a very small amount and peak this out. And I can see that nothing is happening with it. So I'm going to try doing it up here. And you can see it's working. It is totally, it's almost like an extrusion in some ways. But I just want to use a very small amount to kind of pop this value out. So if I highlight the ends and do a little bit of work on this peak, I'm going to just inch it out ever so slightly. So it's just hugging that geometry, but you can see there's a slight gap around all of these little, between these splines and the underlying geo. Maybe I'll bring that back to even smaller value, like 0.3, something like that. So now when I say, hide other objects, we've got our splines here. And if we go over to, let's just quickly do a little mantra render. So I'm going to hop back out to the output context, and let's throw it on a mantra node. And I'm going to also throw down a light. So I'm going to move over the top of my geometry like this. And I'm going to control click an area light. And that just puts an area light in the position wherever my camera was. Cool. So now I'll switch over to the render view and fire off a render. I'm going to choose camera 1 and click render. So you can see here it started rendering our geo, but our splines are way too thick. And in Mantra, we can control the width of our splines using a width attribute. So I'm just going to type attribute create. And if I'm just going to hide the initial extrusion for right now and jump in here, and in our attribute create, I'm going to say width is our attribute. It's a point attribute, and let's give it a very small value like 0.002. So when I click render, these splines should all sort of render with a thinner width. And there you can see our splines beginning to appear. Let's now that we've done that and gotten sort of that Mantra version of it dealt with, let's create a Redshift version. So I'm going to just take this attribute create, only really works with Mantra, I think. I'm not sure, but I'm going to just create a null to denote that this is the render setting for Mantra. So Mantra render. And then we'll create another stream over here for Redshift. Throw down another null and call this Redshift render. I'll set the display flag here. So now, if I go up here and I'm looking at my geometry here, I'm going to add a new tab here, and we're going to just add the Redshift render view. There's nothing in it, and if I were to try rendering this right now, nothing would show up. You can see it's just rendering a blank image. So what we need to do is tell Redshift that we want to render strands. Strands are sort of their version of particle render, or of spline rendering. So I'm going to say check this box, render object as strands, and I want to do a strand type of strip for now. I'm going to bring the max tessellation subdivisions down and just leave the default scale at 0.01 for right now, and we can adjust this later. So let's hit render again. And you can see our splines are starting to show up there. It looks like the width is a little large, so I'm actually going to stop that. And let's actually, for this Redshift render view, if I go back to our output context, you can see it's created these two new Redshift nodes for us. We've got a Redshift ROP, and you can see it is rendering our splines as such. Just to be sure, I'm going to add a Redshift light instead of this area light, so I'm going to go back out to our scene view. I'm going to go to the Redshift shelf. If the Redshift shelf doesn't exist for you, you can add it under here. Hit the plus icon, and there should be a Redshift shelf down there. And then I'm going to create an area light, just this RS light, and I'll just hit enter. And that creates it at the origin. And what I'm going to do is, because the area lights in this position, if I wire this in as a parent, because this doesn't have keep position when parenting checked, it should pop into the position of the area light. So boom, now our Redshift light is in the same position as our other area light. And then what I can do is actually say keep position when parenting, and then use the Y key and slice through this. So holding down the Y key and slicing, the Redshift light stays in the same position as the area light. And then I can turn the area light for Mantra. I can just turn it off. So I'm going to just untick this enable option here. Let's get all these things over here. Let's kind of organize this like so. So now go back over to the Redshift render view, and let's just dial back the spline, the default scale a little bit. I'm going to bring this down to maybe 0.002. And then instead of using a strip, I want to use a cylinder. You can choose different shapes. Like these are the shapes that will be swept along. So box will be like more like a four-sided sweep, and then cylinder, it tries to create like a rounded a rounded poly wire around it. So let's go with cylinder. Capsule is a little bit overkill. I think it actually ends like a rounded cap to everything. We're not really going to see any of that, but you could do that if you want. Also, cone is more like hair, where it tapers off to one end. So let's just stick with cylinder for right now. And then I'm going to hit render again. Nice. And if I just bring down the light shader intensity multiplier, maybe to 50, oops, 50, you can see that we're starting to get that that nice spline shading here. I think these might still yet be a little bit too thick, so I'm going to bring this default scale back to 0.001. You can see that it didn't update. So a lot of times with Redshift, when you're messing around with these spline objects, the IPR won't be refreshing it right away. So you'll need to just hit this refresh IPR button. And then it'll rebuild the geometry. And you can see that it's much thinner now. Now if we turn on our initial extrusion, you can see it's starting to appear under there. Get a little bit more detail in here. I'm going to just throw down a Redshift light dome. And it hasn't updated. I'm going to refresh. And you can see everything's starting to render like so. I'm going to just bring back the intensity of this light dome to maybe 0.1, 0.01. And then there's no global illumination, so I'm going to switch to the output context. On the Redshift drop, I'm going to select the Redshift tab, go over here to global illumination, and let's just turn on brute force for the primary engine and brute force for the secondary. And going back to the object level, might bring this light dome back a little bit. Let's turn it off. Leave it on. And really the only thing that's left to do from this point is to add your own Redshift shaders and kind of tweak this stuff around, get the lighting how you want it, and you're there. So I hope that you found this lesson interesting. I know that this is a little bit more complicated of an example, but this is really our first dive into, you know, fully like utilizing the powers of attributes and groups, promotion, and then doing some using attributes to do some tricky problem solving and glitch fixing and all that kind of stuff. So I hope that that was beneficial to see. Obviously, if this didn't all sink in right away, repetition is everything. Come back and watch this lesson a couple times in the future. After you finish the course, come back and watch it again. You know, things will maybe start to make more sense to you later on down the road. But I felt really at this point, it would be a good idea to have a lesson that really kind of delves into making something like production quality, you know, glitch free, beautifully controlled setup like this. So that's it for this lesson, and I'll catch you in the next lesson.